So we kick off with one of the most important phenomena associated with light, that is the reflection of light. We all know what is reflection, but we'll dig into further facts about reflection, laws of reflection, mirror law and whatnot. So let's start off with reflection through plane surfaces. So let's watch out what's in store for us. So let's start with the first event corresponding to the light, that is the reflection of light. Now, without insulting the knowledge which you have, I straight away begin with my version of reflection of light. So, according to me, the reflection of light is kind of similar me throwing a ball on the ground at a particular angle with the vertical. What happens is after colliding, after the ball collides with the ground, it's sort of directed to a new direction. It starts moving in a new direction after collision. That is the same event which is taking place in case of light. Now, we have studied that one of the ideas corresponding to the light is that the light is consisting of very small particles which has matter. So it's like a stream of balls, small balls are coming and hitting the surface and then moving on. Now, if the condition corresponding to those balls, that is, they should undergo elastic collision, then this angle, let's say, is called as the angle of incidence, will be equal to the angle of reflection. So the condition that all those tiny balls are undergoing elastic collision governs this fact, that is, the angle of incidence is equal to angle of reflection. That's the reason behind laws of reflection, I equals to R. Now, there are two types of reflection. One is specular reflection, the other one is diffuse reflection. Now, if an object is undergoing specular reflection, then I won't be able to see that object properly because I don't have two light rays, at least two light rays to locate the image of, or let's say the location of the particular point. Whereas I do have at least two light rays coming from a particular point describing its position. So the different objects which we are able to see around is only because of diffuse reflection. If it's a specular reflection, the object will simply look like a big shiny silvery thing. That is, I won't be able to figure out what its shape or size or the texture is, whereas in case of diffuse reflection, I will be able to do so. So these are the two types of reflection. Now we will ponder upon to the other aspect of reflection, that is what we are actually witnessing when the object or the light from an object is undergoing reflection. Now, for that we need to study about images. Now, images is basically a collection of points. So, images in a nutshell is collection of points. And what those points are actually? So, those points are basically the point from which or from where it appears that the light rays are coming. That point is called as, let's say, an image point of a particular point. Collection of those points, it's called as image. It's not necessary that the light is actually coming from that point. It can be the case that it appears to be coming from that point. That's also another case. Another beautiful fact about the image is the light rays shouldn't be from an actual source of light. That is, a light source shouldn't be present at that particular point. Then that point is not an image point, that is an object point. So the light ray is not originating from that point. It seems to be originating from that point. And the point which I am talking about can be real or can be virtual. It can be actually the case that the light rays, they are coming from 2 points or coming from a single point, 2 light rays. The other case is they're not coming from one single point. It seems that they are actually coming from those 2 points. There are 2 different scenarios. It's like I was standing over here and a friend of mine was actually standing over here. Then I sort of moved in another direction and my friend sort of moved in another direction.
So if you saw the whole event, for you, it might be the case, or let's say you will call that we actually originated from a particular point. But if I sort of expose you to this event in midway stage, that is, I was moving in a particular direction and my friend was moving in a particular direction, you being a scientist, you will call that it seems that they started moving from the same point. But it can be the case that I was moving starting from the other point and that guy was starting from the other point. But you, a third eye, it seems that for you, I am or my friend, both of us, we are starting our journey from the same point. So that's a virtual image point. The other one, the previous one, which we talked about, is the real image point. So image, please make this concept uptight about, because it's very important in the later stages of the chapter. That is, image is simply the collection of points from where the light seems to be coming. And there's no luminous object actually at that particular point. Now, the different type of mirrors which I can have is, one is a plane mirror and another one is a spherical mirror. So we already know the different types of images, the characteristic of the images formed by the plane mirror. So I've listed down few of the characteristic of it just to be on the safe side. So the image is obviously upright. That is, if I'm standing like this in front of mirror, I observe myself in the same orientation on the other side of the mirror. And the image is same size as you are. That's also pretty obvious. We have witnessed that. The image is located as far behind the mirror as you are in front of it. Again, that's correct. That is, the object distance. This is the object distance is equal to the image distance. That's the few properties of the images formed by the plane mirror. Now we come to a different type of mirror, that is the spherical mirror. So spherical mirror is basically made out of a glass sphere. Okay, so this is a glass sphere. So it's an hollow glass sphere with a particular thickness. So I cut out a particular portion and we end up getting a substance with which we can actually make up a spherical mirror. It depends upon which side I silver it, that is, which side I make it as a reflecting side. Then in one case I'll end up getting concave mirror, in another case I will end up getting convex mirror. And this point C is called as the center of curvature. That is, it's the center of the glass sphere from which this piece of glass was extracted. That's C. Now F is called as the focus. It is actually a special point. That is, I don't want to expose everything about the focus right now. Just make sure that there is some special point named as focus, labeled as capital F, and the focal length is equal to R by 2. That is, in this particular case, it's FB equals to CB by 2. That's the condition. For a while, the focus is just a special point. We'll learn more about the focus in the coming slides. Now, the different types of uses which we have of spherical mirror is, in case of convex mirror, we use it as a rear view mirror. That is, the objects which are behind me when I'm driving the car, those objects seems to be closer to me than they are in reality. That's because of the convex mirror. So the convex mirror is basically used as a rear view mirror. Now a concave solar concentrator is basically a device where I can focus all the light rays coming from sun to a particular point. That is, I'm converging a high amount of energy at one single point. So with that amount of heat or thermal energy, I can definitely be doing something useful. So concave mirror is, or let's say the concave mirror, the reflection due to the concave mirror is the underlying principle between the concave solar concentrators. Now, in order to study the image formed due to reflection or any other phenomena, I need at least 2 light rays to originate from a particular point. Because if I only have a light ray, and let's say this is an eye, I know it doesn't look like an eye, but let's say this is an eye, then if the light ray is hitting my eye at this particular point, then I will perceive that the light is somewhere coming from different points along this line. But if the light from the same point comes and hit me at a different point, then according to me the light is coming from somewhere in this point. So hence this is the common point. So at least I need 2 light rays to correctly point out the position of the image, thereby knowing everything about the image. Now I can obviously get on with multiple light rays, that is I can use 3 light rays, 4 million, a billion light rays, but I don't want to make myself clumsy. So we'll always work out with 2 light rays, the minimum. Now, before learning more about the reflection through spherical surfaces, we need to make sure that we'll set a few ground rules. So first up is when the light moving, or let's say propagating parallel to the principal axis hits the concave mirror, then after reflection it passes through the focus. That is, any sort of parallel light ray after reflection will pass through the focus. Now this focus is not, let's say, famous or an important from a physical point of view, but you can definitely prove that R equals to 2f, f being the focal length and r being the radius of curvature. It's a simple geometry which involves circles and perpendiculars and the radius. So you can easily prove that r is equal to 2f. That is, f is a point where the parallel light rays after reflection from a spherical mirror meets. They converge. So that's one property. The other one is when the light ray passing through the focus, after reflection from the spherical surface becomes parallel. This is the other property. The next property is when the light ray is moving or it's coming from center of curvature, it hits the point on a concave mirror. After reflection, it retraces its path. So these are the 3 basic properties which I need you guys to keep in mind, because based on these 3 properties, we will be dealing with the different types of images which are possible by using the combination of convex, concave, plane mirror and everything. So these 3 ground rules will help us deal with the problem in a much better sense. Now, these are the same things which were discussed in the last slide, that is initially parallel to the principal axis and therefore passes through the focal point after the reflection. Same goes for the R2, where it initially passes through the focal point and it becomes parallel after reflection. Then the third one comes in, that is the ray travels along the line that passes through the center of curvature. It kind of retraces its path back. So it's just put in the words so that you better understanding and you do have a slide to go back to whenever you're getting confused.
So we just discussed what is a plane mirror and what are the different aspects of reflection associated with the plane mirror. Why did we pick up plane mirror? Because as I told you, we will be discussing about reflection about the plane surfaces. So now that we are done with the reflection about plane surfaces and its application, its various details of images and objects, where will the image form, when will it be formed. So now that we have covered all these aspects, so now we will move on to the reflection through spherical surfaces.